All right, I think we're up to the official time, and we'll let people wander in. All right, so I've been studying Android app security for several years. I started with the top banks, insurance companies, and stockbrokers, and the OWASP top 10 of things you should not do on a mobile device, and they're all doing some of them. The most common thing they're doing is not putting any integrity controls in their code, so I can modify the code and put a Trojan app up, and it'll still contact the bank. So I can put in code that steals the password, sends it to a third party, and so on. And in general, they don't care about that. Now, some of them now care about broken SSL because in 2014, 2 companies were sued by the FTC successfully for that and punished. That was Fandango and Credit Karma for not validating SSL certificates. And that continues to be a common practice, but when I notify people about that, they'll actually fix it. Most other things they won't fix. So anyway, I teach at City College San Francisco, and you can reach me on that Twitter, and all these slides and everything are on my website, samsclass.info. You can get them there if you want them. So here is a simple problem, which I must say, I thought this problem had been solved decades ago. Suppose you want to have a user and they don't want to have to keep logging in every time they open your page. There's supposed to be persistent login, so you have a checkbox someplace that says, remember me, and then the app remembers you. Well, gee, I didn't think this was revolutionary. You put a cookie on the machine, and the cookie should just be a random number that does not contain any personal information because it's not going to be stored securely on the machine. So you put a random number on the machine, and you put a database on your server with that random number that tells you who it is. This is not rocket science, but I don't know why the Android developers never found out about this. There are a few people that did, like Target Australia. So I went through the top retailer apps. About a year ago, I just struck my fancy. And so I went through Target. Here's the Target Australian Android app. It's just one of the ones out there. So you install this thing on your Android phone. And if you log in, you send this request to the server. It goes over HTTPS. It's encrypted, and they validate the certificate the way they ought to. And so you send up your name and password, but this is fine because it's encrypted. And in the response, they send you back a long random number. This is what you should do, and this is what I thought every web app did. They send you a random number. That's not your username or your password or anything much. It's just a random number. You save that on your phone, and now you don't have to log in. Every request you make has that cookie, and Target Australia knows who you are, but nobody else does. So that's fine. Then let's take a look at Staples. There's the Staples app as it was in January of this year. So you download this thing, and like every other loyalty app, it has a login that would take you to something. And when I look at the local storage on the Android phone, I find something called encrypted password. Now, right now, I can stop and say these people are idiots because they should not be storing any kind of password on the phone. Now, when I did my auditing previously of bank apps, I would not report this or make a big deal out of it because I said at least they encrypted it somehow. And I wasn't energetic enough at that time to check the encryption, but now, I'm deciding to look more deeply into encryption. So I said, well, they say it's encrypted. I wonder how encrypted it is. However, already I can say that this is a terrible practice unless they're lying, and that's actually meaningless or something else, which would be cool. If somebody would actually get sneaky like that, that would be security. But if that's really some form of your password, then the wheels have fallen off the bus here already. So here I found a website. By the way, I found some old Android websites with opposite advice, saying, oh, just store the password in plain text in every apps folder. It'll be fine. The operating system will protect you. And I'm like, dude. But anyway, these guys have good advice. How to store sensitive information on your phone. Best way, don't. Get over it. Store sensitive information on your server and store a cookie on the phone. You don't need to store anything on the phone. If you think you do, you just haven't thought this through. But if you have to, there's the Android keychain. They wrote it just for this purpose, to hide secrets. Why don't you use it? Almost nobody uses it. I only found one app that uses it, and then they don't store your password in there. They just store other things in there. Another thing you could do, which nobody anywhere, I've never found any app do it, if you really wanted to do this, you could use this miracle called public key encryption. You could encrypt that password with your private key and store that result on the phone, and nobody can open it. Encrypt it with your public key. And nobody can open it except you who hold your private key. That would be completely fine. It'd probably even be safer than the keychain, but nobody does it. A lot of people just put it in plain text on the phone. but some people in the last year or two, for some reason, they say there's been a revolution in Android app security, and they've moved from number 5 up to number 4. So the current most popular technique is to store your password on the phone with private key encryption and then try to hide the key on the phone somewhere. This is as much use as locking your door and putting the key under the mat because I can see your source code. How are you going to hide that key from me? The answer is, you're not. You're just fooling yourself, and I don't know why. But anyway, so here's a trick I learned from the Burp Suite book, Pen Testing Web Applications, a Web Application Hacker's Handbook. If people are stupid enough to store an encrypted password on the phone, then you might be stupid enough, since they apparently don't understand encryption at all, they're probably going to be dumb enough to use textbook encryption. This is called electronic codebook mode, and you can find out by using this special password, 32 characters all the same, and then a few more characters to meet whatever their password complexity requirements are, because if they're using an encryption routine, it's going to have a block of 8 or 16 characters, and this is going to have 2 identical blocks of 16 characters. And electronic codebook mode is a mode of encryption that people use who are beginning students learning encryption, and after they get out in the real world, they never use it again, because every block of input encodes to a block of output, and if you have a second identical block of input, you get the same block of output. So I wonder if they're dumb enough to fall for that. And if you look at this encrypted version of that password, it doesn't look like it. I got 5v/, and there's not another 5v/. But remember, that's base 64, so you're seeing the bits 6 at a time there. If you just decode it into base 16, then you can see that indeed it has a block of code, another identical block of code. So in addition to using encryption when they shouldn't be using it at all, and using private key encryption when they should be using public key encryption, they're using electronic codebook mode when they should be using another mode like cipher block chaining. So if you look at, now the question is, where's the key? So since people don't bother to obfuscate their source code at all, I can just grep for the word password in their source code after taking it off the phone. There is a worthless product called ProGuard, which you can turn on if you don't care at all, because it does absolutely nothing. It turns like 3/4 of the code into garbled junk, and the rest I can just still read. So it really is like, it's like a guard that locks half the doors and goes home. Anyway, so I can just read their code. So there's this thing called username and this thing called encrypted password. So here they are calculating the encrypted password, running this function called M to encrypt it. And if you go look and see what that function called M is, this is what it does. It takes the brand of the phone, the device identifier, the model number, the serial number, and the package name, which is like Staples app. It combines those together, and it adds this thing called extra salt at the end. So then it runs it through SHA-1, and it takes the first 128 bits, and that's the key, the encryption key. So that is their hiding the key on the phone. Extra salt, the name of the phone, and all that jazz. And so after you combine together those easily accessible bits of information and get the key, you can then decrypt the data on the phone. So here's my 32-character A hexadecimal. I can decrypt it in AES and electronic codebook mode and get back to AAA. Now, you can use online utilities like this just to make the point of AES encryption, but in fact, it's very easy to do in Smali. So I told them in January, and I got an automated response saying, thank you for your interest, we'll fix anything you talk about. And I said, sure you will. So they did nothing until April, and then they became homework, which is what I do, be warned. I give people 30 days notice, and after that, they become homework. So I gave my students the assignment to steal my credit card number out of my Staples account, and I wrote videos showing the first one, that they're using the wrong mode, and the second one, how you could easily just completely reverse it and recover all the stored data off the phone. And then they did nothing and didn't talk to me. And I went to a federal conference in Washington, D.C. to demonstrate it. And when I demonstrated it, it was finally fixed. And this is what happens. I've done this for years. You humiliate them, and then you humiliate them more, and then you humiliate them more, and at some point they actually fix it. So when I tried it there, this was the patch. The app will no longer run on a rooted device. So I strongly suspect, although I haven't had the energy to go check, that all I have to do is unroot my device, put on the app, save the password, root the device, and suck the password off. But technically, the exact procedure I reported to them no longer works for this reason. And this is what you usually get. We have patched the vulnerability you reported. And this is why there are so many vulnerability reports that say, I told them They made me wait 6 months. They patched it. I hacked through the patch. They made me wait 6 months. They patched it again. I hacked through the patch again. And this goes around a few more times before they finally do something that actually fixes the problem. And I'm not trying to be terribly sarcastic and abusive to developers. I know they got work to do. You're busy, and real customers aren't complaining, so why do you care about this random idiot bothering you about obscure problems that are hard to understand and hard to fix? But anyway, that's what I do. So then there's people that just throw caution to the winds and put your password in plain text in the app folder on your phone, like Ace Hardware, McDonald's, and Menards. I told them they don't care at all. They didn't fix it, so you just look in the Ace Hardware data directory on your phone, and you'll find your password just sitting there and your email address. So this means, now, if you think about operating system design, there was a time when operating systems worked like this, long, long ago. There was a Linux password file that actually just had your password in it. And around 1975, the Unix world figured out that was a bad idea, and they started hashing your password. And MS-DOS, I'm not sure it did that, but I know Windows 95 had an encrypted file to stick the passwords in, and each version of Windows up to Windows NT had an improved version of hashing passwords because they understood that having a file on your machine with plain text passwords is a monumentally bad idea. People will find some way to steal that file, and then you've lost passwords. And see, if you mess with a user's password, you are really messing with their whole life because 95% of people reuse passwords. So the password they use in your tiny little app to get $5 off a hamburger is the same password for their email and their bank and everything. So you really should have some respect for their password and not just throw it around like trash. So Android, which is pretty bad in security, especially in the earlier versions, doesn't store your password in plain text because it's based on Linux, and Linux quit doing this decades ago. It has a secure storage of your password in the operating system, but each app you add to your phone makes an extra, completely unnecessary copy of your password in the app directory. And if they're going to do stuff like this, you put 50 apps on your phone, there's an extra 20 copies of your password all over the place on the phone for no reason at all. I do not see any logical reason for them to store the password on your phone. They could just use a cookie. They've already got a website, and the website login probably uses the cookie. I'm baffled that it is so popular to design apps in this crazy way. But anyway, for their convenience, they store the password on the phone, and these guys store it in plain text. These people go so far as to spray it back to the server in plain text over the internet for more fun, 7-Eleven and Trader Joe's. This is not the official Trader Joe's app. This is the Trader Joe's fan app, which somebody else wrote, but it does take your Trader Joe's login and send it over the air unencrypted. This reminds me of the Spirit Airlines app. I was doing airlines a few years ago, and I found a Spirit Airlines app, and it had total plain text login. So I contacted Spirit, and I said, hey, your app logs in over plain text. And they said, we don't have an app. And I'm like, well, somebody wrote an app and put it in the Android store, and it's pretty much a piece of junk. And they said, well, gee, I don't know. And I heard this happen, too, when Android was new. Somebody put in a banking app, and the bank didn't know. They said, we don't have an app. Well, they don't verify your identity, especially Android, so you can just send up an app, and it'll stay up there for a long time before somebody notices. You can do anything you want with it. So this is what you see if you run through a proxy. I'm using Burp. I have HTTP requests, not encrypted, and it just sends your password naked over the internet, which is, of course, appalling. This means everybody in the coffee house you're in, and everybody at your ISP, and everybody at the server, and everybody at the other ISP, about 100 people can see everything you're doing. And if any of those people are infected, it'll just harvest these things and make a list, and it's bad for you. So I was at one of these boring faculty meetings they made me go to, where we were talking about something for an hour that I couldn't care less about. I just found a power outlet in the back, and I started testing apps. I was going through them alphabetically, and I tried Amazon. And Amazon has about a dozen apps, and they're all pretty secure, which is what I would expect. Amazon are pretty much professionals. They know what they're doing. They're not going to make these ridiculous, stupid blunders that I'm looking at. But this thing called Price Tracker for Amazon is not made by Amazon, but it uses Amazon. And if you want to buy something, it will watch the price fluctuate until you can buy it at the price you want. And it does that by logging in for you at Amazon. And it doesn't bother to validate the HTTPS certificate, so it exposes your Amazon password to theft. So I found that. I notified the author. And unlike most of them that just completely ignore these notifications, I got an immediate answer. I said, dude, your app breaks SSL. He said, yeah, I just added that latest version. Do you like it? I'm like, dude, You turned off an important security setting you didn't even tell the user. He said, yeah, that was my important. See, people were getting this blank page that encryption was not working, and they get weird error messages, and they were complaining. And I said, hey, if you just turn off that encryption, it works great now. If you go into advanced features, you could turn it back on, but what would you want to do that for? And I'm like, dude. But anyway, that's a feature, not a bug. And I said, you know, people have been punished by the FTC for doing this. You can't, like, turn off the encryption and not tell the user. And he said, oh, well, I'll fix it. But then he didn't fix it. So here he is, public humiliation. Anyway, here's people that do something Microsoft used to do, and they called it reversible encryption, which is a kind of euphemistic term for utter stupidity. They don't want to store your password in plain text, so they encrypt it and then hide the key somewhere. And there's a hacking tool called Mimikatz and another one called Windows Credential Editor and a whole bunch of others that are someone figured out how to find the key, decrypt the password, and now you go to town, they might as well store it in plain text as do that. But they do. And so here's Home Depot, Kroger, Safeway, and Walgreens. They all do this. And I notified them all months ago, and they paid no attention. So here's Home Depot. Your local password looks like this encrypted password, just a long blob of base 64, actually 3 blobs of base 64, ending with equal signs, turning into 3 numbers. So if you want to understand what's in there, you get the source code. To get the source code, you just connect to your phone with Android Debug Bridge, list the packages, and find the name of the package, then suck it off with ADB pull, pulls the APK file off the phone, you unpack it with APK tool, and now you've got all the source code. And now you just grep for convenient things like encrypted password in the source code. And it shows you, just because nobody bothers to obfuscate their code at all, you can just find a variable in there named password and find out how they did it. So here's the encrypted password, and right here I can tell they take some kind of seed, they run it through the password key derivation function to make it into a key, and then they encrypt it with AES, and they use cyberblock chaining mode for whatever good that is. So they're one step ahead of the last guys with their electronic codebook mode, but they're still using private key encryption on a device that has nowhere to hide the private key, which is a fundamental logical flaw. So here's what they do. They take this constant string called public password PDK-BF2, and that's what they use as the seed, run it through PDK-DF2, which hashes it 100 times or something. I think 256 times, yeah, hashes it 256 times. And the result is then used for the key. So it's always the same. And so I added Trojan code to it to verify this. I found the encrypt routine that takes in plain text, key, and salt, and I put them in the log. The stuff in the blue is the Smali code I added to the app. Then you just recompile it, zip it up, sign it with my own signature, and it runs on the phone. Don't ask me why. Android makes you sign the apps, and then it doesn't verify the signature. So you just sign it yourself, and it doesn't mind that it was signed by a company last time, and now it's signed by me. So I don't know what the point is. Yeah? I don't have any development. No, I sign it with a self-signed key that goes nowhere, and it swallows that. You can do that. I don't know why you bother making people sign things this way. A lot of Android security is what's called security theater. You know, like where they put up a sign and say there's a dog and there's really no dog. By the way, the same thing's true of my Windows code signatures frequently. I went to a talk about a year ago at one of these security conventions. They said how to modify signed Windows binaries. And I'm like, dude, how's that possible? Well, the binary has 7 sections, and they only sign these 3 sections, so you just put the malware in the other sections, and it sails right through. And I'm like, dude. A lot of these defenses are a whole lot less useful than they pretend to be. Anyway, so this is what happens. When I dump it out, I get the key and I get the salt. And so then I was able to write a little Python script that will just totally do it. You get these 3 blobs, and you decode the blobs, and you can totally decode the encrypted stuff. This I'm encrypting my password to reproduce it, but it just takes 3 or 4 lines of Python to do this. You're just doing the standard cryptographic function. So these brilliant cryptographers have spent 100,000 hours perfecting these wonderful techniques. Then they hand it to the developers who pick them up like a kid that takes a hammer to drive a screw and just go bang, bang, bang. Let's use AES there, now it's scrambled. It's a shame. So here's the complete decryption. I can get back to my password here by just decrypting it with that key, and all the information to derive that key is just stored on the phone in those base 64 blobs, and all you have to do is run them through the standard functions in their standard modes to get there. This is the complete script that starts with the file you sucked off the phone, finds the blobs, reverses them from base 64, and then just performs the key calculation and decrypts the data on the phone. So I started doing this, and then I would send them a vulnerability notification to say, you know, you've encrypted this stuff, and anybody can just run this Python script and decrypt it, but they don't care. So here's Home Depot being reversed with, I can send in my, I can just recover the stored password there. I'm using capital P @SSW0RD, an old Microsoft test password. And all right, here's Kroger. I can recover the mess on the phone. Here's what they stored on the phone. All that junk just decrypts to your username and password without having to guess at anything. All the data you need is stored in that mesh. And that's all the code it takes to do it. The first bit is the salt, the next bit is the IV, the next bit is the ciphertext, and they've used a fixed password that is always that long mesh starting with 64 that's hard-coded in the app to generate the secret key. And that's not what a cryptographer would actually refer to as a secret. It is a curious use of the term. Here's Safeway. They have stored things on the phone called private user seed, password seed, and private salt, and of course you can just use those to calculate the real key with a couple of lines of code and recover the username and password from it. So it's, you know, it's a useful exercise for beginning cryptographers to reverse these things, but if anybody actually wanted to protect their users, they should be paying more attention to what needs to be done here. Here's Walgreens, and I thought they might care more because of HIPAA. And by the way, I think Walmart was really quite good, which is what you'd expect. They're, I think, the #1 retailer in the world. You would like to think at some level of wealth, they would actually pay for developers and security auditors and stuff that would do things right. And some of the, and like say Amazon are not idiots. I can't find any mistakes this stupid at Amazon. They're smarter than me, so they pass my tests. But Walgreens doesn't. Walgreens is special though. The encryption key is always exactly the same, and they calculate it from a seed, which is just hard-coded 3 places in the app, PHW584. And so you can find that and just run it through PBKDF2, and then you get the key, which never changes, and you can now recover the password off the phone from this long blob of junk. That long blob of junk is looks like JSON. It's JSON including a lot of things, including your password, just right there. So this is a very popular activity to store things in this manner. And then there's people that hit the trifecta, like Publix, the plaintext password storage, broken SSL, and Delhaize, which I think is some kind of retailer it's like the top #9 retailer in the world from some other country. And they had the password in the log and stored it locally insecurely and sent with broken SSL over the internet. So it's the trifecta. And I told them, and they don't care. A few people fixed it. Golf Galaxy actually fixed it, which is one of the apps from a major sports retailer. They fixed one of the vulnerabilities I told them about. JP Morgan Chase actually took it out of the log. This is actually a surprisingly common vulnerability. I must find it in something like 2 or 3% of all the apps I test. They just put the password in plain text in the log. Now the log is the Linux syslog. It's available to every app on the phone. So you might as well, you know, it's terrible. It's like putting it on the SD card. You're like, who are you kidding? Every single app can steal it. And I think people are just coding things and they put it in the log, like the password, and then they leave that version and ship it off. So people have even sent me like apologetic letters saying how their version control slipped, you know, how they can do a horrible thing like that. I think it's the same thing with broken SSL. I think they can't be bothered to import a certificate on the phone to trust their proxy, so they turn off SSL to test the HTTPS, and then they don't turn it off back on when they ship the production version. But it's surprisingly common. Options House, financial investment apps are really appalling, and Options House had broken SSL for 2 years after I notified them, and then they finally fixed it. I don't know. It's interesting to see how long really bad vulnerabilities will sit there. Like I say, most people will now fix broken SSL since the FTC acted on it. So I was pretty fed up at this point. Why are people storing your password all over the phone? So I decided to teach a cryptography course. So I'm partway through it this semester. And you know, I don't really care about teaching people to be expert mathematicians. I just want to teach them how to use the standard tools that are out there. There's really only 3 or 4 encryption routines you need to know, and you should learn how they work. So you don't do stupid things like use private key encryption and then have a private key that you don't know where to put it. There's other things to do. That problem has been solved decades ago, And if people would just, so anyway, I have an engineering sort of cryptography class here where we just focus on correctly using these things and cryptocurrencies, which is, of course, a big hit as one application of all this cryptography. Anyway, as I kind of thought, I have a little time left over, so I added something here that I thought was good, clean fun, and I was even getting in trouble with this earlier. So this is another old attack. Everything I'm telling you is really old, by the way. This technique of taking the source code off the phone has been known for a long time. So let me go here. I'm going to stop this one and go here. Stop this one. Okay, Control-C, I say there are, and restart it. Okay, let me start here. I've got a virtual machine here running Linux, and if I do ifconfig to get my IP address, it's 192.168.90.18. So what I want to do is put myself in the middle. Now, I can do that for a normal browser out here. If I open Firefox, I can set a proxy to put that device in the middle. And of course, if I was doing this in a coffee house, I would use ARP poisoning to redirect the traffic, or I could turn on an access point and could trick people into connecting to me instead of the official access point, and that would put me in the middle. There are a lot of ways to do it. But here I just do it artificially to make it easier to see. So I turn on the settings. I'm going to turn on a proxy, which is going to go through that address, 192.160.90.18. All right, 192.168.90.18. And what that will do is take the traffic from Firefox and run it through this box. So if I go to an insecure website like Bing.com, it will, of course, well, that's rude. Oh, I have an extra apostrophe or something there. Hold on. There we go. So I open Bing. Bing is not a secure site, which in itself is kind of a curious decision considering searches are somewhat private. But in any case, that's by design, and I wouldn't report that as a vulnerability, and that's the way lots of search engines were for a long time. So Bing is now passing through this box on the way to the internet, and it doesn't warn you. And that is fine because it's an HTTP site, and HTTP sites have no integrity. So if you type yahoo.com in your browser, you have no idea who you're talking to. You're talking to anybody that answers the call for Yahoo, and you hopped through any number of intermediate steps and ended up wherever they chose to put you, and you have no idea. So that's HTTP. It's best effort delivery. It has no pretense of being secure. But you notice they have a sign-in button on the Bing site. Now that's a little disturbing, because that means I can log into Microsoft from Bing. Now, let me just do this in Chrome for comparison, since I got a minute here. If I go to Chrome, and I go to Bing.com, all right, and I click this login button up here. Let me make it bigger if I can. All right, so I sign in comes an opportunity to connect to Microsoft. I click that button, and I end up at a page that is secure, HTTPS. And Chrome is a good product, and it verifies the certificate. And so now I have very high confidence that I'm actually talking to Microsoft and that nobody else is going to read this stuff, so that's good. But if I go to this one, here it's going to complain because it doesn't fall for this anymore. So let me talk to you about what's happening here. I've turned on a special proxy here called SSL strip, and I think I have a slide about it. Yeah, all right. So this is a proxy written by Moxie Marlin Spike almost 10 years ago and presented to the security community. It is bloody brilliant. You have a proxy that connects to the internet over HTTPS and then serves those pages over HTTP. So your browser will go to a site that should be secure, but in fact see an insecure version of it. Now, if the company actually switched to HTTPS and put on the HSTS header in their requests, or they wrote an app on your phone which knows it should be talking HTTPS, you can't fool it with this because it will try to connect with HTTPS and not HTTP, and when this proxy tries to make an HTTP connection, it won't fall for it. But what really happens is people have an insecure website, and then they start thinking about making it secure, so they try to secure just a login page or just the customer details, and so they have mixed content, so that not everything is secure. So, and typically what they do is they take the old HTTP page and put in a 301 or 302 redirect to the secure page. So they pass through an insecure stage on the way to the secure stage. And SSL strip proxy changes all HTTPS URLs into HTTP. So if you pass through an insecure stage, I'll catch you. Now, Bing was vulnerable for years, and I used them as my example and for my students to have homework with steal passwords out of Bing, but they finally shaped up. People, after enough humiliation, people do shape up. So I just did a search, and you can find a lot of them. Barracuda, for example. You can just, by the way, do a Google search for HTTP in the URL and a login button. This means they have an insecure page that has a link to a login. That's all I need. And so Barracuda Networks has it. So let's go back to here. And if I go back to Bing, which is a handy search engine that's not secure, and I search for Barracuda, who make firewalls, and one might imagine we're concerned about security if one were that kind of person. This is a belief people have until they actually test the security of security companies, and then you discover that they're in no way better than other companies. So go to customer login, and it's loading a sign-in page through my proxy. Okay, here we are. Oh boy, I'm all ready to log into Barracuda. And notice what's going on up here. No padlock, no HTTPS. I'm in an insecure Barracuda login site, which is not the code they wrote. It's the code my proxy wrote, modifying their code to just take the S out of the HTTP. Now notice this. Firefox is tired of this nonsense. And since the people that run websites have not fixed it, they have decided to fix it unilaterally. It's warning me there's something wrong with this connection. So if you'd have to ignore that warning to proceed, and if you do, of course, your host, test@aol.com, secret, password. But you know, you can't say they didn't warn me. Firefox warned me. If I'm dumb enough to do this, then of course, I'm going to see that password stolen here. And so let me turn on my log. There you go. So there's my test@aol.com and my secret password being revealed, stolen by someone in the middle. So when I saw this, and there's a bunch of other sites that are vulnerable, I thought, well, maybe I should stop picking on them because even though they never fixed their security, the browser manufacturers are fixing their security. But then I thought there's people using off-brands like Opera and stuff, and I don't know how long it'll be before they start putting up the warnings, but they probably will. But the real category of devices that people use all the time is phones. And phones don't have any warnings like that, and they probably never will because you don't have much real estate on the phone, and it's hard to justify wasting it for something boring like a security warning. So I started testing phones, and that's when I knew I was off to a good start here because things were vulnerable that I had not anticipated. So here's other ones that are vulnerable through the browser, Constant Contact and ADP, the people that print everybody's checks. They're vulnerable to this attack, but the browser warns you, so I would say that limits the actual harm that's likely to hit a user. And here's how you find this stuff. If you want to find sites, it's just log in or sign in, and in URL HTTP. If they have that, they are probably vulnerable to this attack. And you can, this is a fun attack. You can run this in a coffee house. Everybody's using the web. You turn on this SSL strip. You start poisoning ARP. Now they go through your machine for a while. You steal their data. Then you turn it off and they go back and connect. Their session continues. They never know this has happened. This is why people say don't use public Wi-Fi. HTTPS was supposed to make it safe, but you know, I had a wake-up call. There's a DEFCON called the Wall of Sheep. If you use a plaintext protocol and you log in on the DEFCON network, there's a place you can go where you can just sniff the network and find the passwords, and they just put it up on the wall, and if you're someone famous like a Cisco engineer, they'll put your name and your profile up there. This idiot used plaintext login over the DEFCON network. So I went there, I got involved with people doing this, and after a couple of years, I was on the Wall of Sheep, and I said, hey, wait a minute now. I was using Gmail. I should have been safe, but Gmail was not secure at that time. The login was secure, and then it switched to an insecure mode and passed your cookie in plaintext, and these guys had developed a tool called Hamster and Ferret that would steal that cookie and replay it. And that doesn't work anymore because Google went 100% HTTPS. And that is a big leap forward, and it makes everybody much safer if you do that, but it is expensive. Especially if you have business partners and advertising people feeding in data from their servers that are not secure, like Amazon. It really is asking a lot, and it's a multi-year, multi-million-dollar task to really move up to 100% HTTPS. Anyway, so here's the Bank of America, for example. If you go to the Bank of America, they have a redirect here. So let me show you this one. This one was just a little bit subtle. So if I go to my browser here and I go back to, say, I don't know if it'll work with Bing. Let's see if it works with Bing. All right, I'll see if it works another time. Is InURL work in Bing? I'm not sure. HTTP. All right, so go to Bank of America. And yeah, I'm not going to push this one. All right, I just want to say this is another subtlety. If you go in Google and you search for the Bank of America, you will see this site called creditcardpayment.net login, Wake Forest University. Somebody made an insecure page. And if you go to that insecure page, it will go to an HTTPS Bank of America page, but it started from an insecure page. And then it uses a 301 redirect, like I was saying. So if you do it, this attack works. I can catch it and send it to an insecure Bank of America login page and seal Bank of America passwords with it, because it passes through an insecure step on the way there. But what turns out to be even more fun is using the phone. So let's go back. Remember, Microsoft was no longer vulnerable. I humiliated them a lot of times, and they actually fixed the problem. Not necessarily because of me, but maybe just because they began to wise up. So here is the phone's browser. And this is Chrome. So if I go to Bing here, and let me make sure that my phone is going through the proxy. I think I already set it up, but just so you see it, I go to Wi-Fi, and then I press and hold for a few seconds to get to modify network, and now I'm sending through 192.168.90.18, which is my attacker over there. So that should do it. My traffic should be passing through there. And so if I go to Bing, I can now hit this sign in button up here and this connect button, and now I get a login. Now they actually do it in 2 stages, which is not a bad thing. So I have to actually be in their database, which I am. So I sign up with a real user account name, and then I give it a password, which is top-secret password, which is not my real password. And then if I go over here, here's sbound at ccsf.edu, and there is top secret password. So it's falling for it. And like I say, even though this is Chrome, generally the most secure, most advanced browser, it is not warning me that here I am on my phone logging in with an insecure page. So that's kind of what I expected. The phones are more vulnerable, so I decided to try a few other things here. And I don't know how many organizers are in the room. We'll see if I can get thrown out of CodeCamp. So let's try Equifax. These guys are in the news. So let's Bing for Equifax and see if they've made this mistake along with every other possible mistake. So here's Equifax's free credit scores, top 10 results. Equifax Credit Bureau. That looks like Equifax Customer Login. That was the one. That looks like good, clean fun. So let's go to Customer Login, and look at this. Sign into your Equifax account. Doesn't that look inviting? So let's sign in with the username of Complete Idiot and top secret password and log in. And there I think I saw some stuff go by over there. Yep, there we go. Top secret password, Complete Idiot. So Equifax falls for this from a phone in addition to other things. And then just before this talk, I was thinking there of some other things. I thought, let's try PayPal. So if you go to Bing, and you know, about 2 years ago, I found all these vulnerabilities in the CodeCamp website. I gave a talk about that. They didn't throw me out, which is cool. And they fixed some of them. So if I go to PayPal, and look at this, there's a login button for PayPal. So I can send money. Yeah, I can send passwords too. Now, to be fair, this page doesn't load very well. You know, I would like to think that a considerable number of users would have a clue at this point that something's wrong. But to be fair, they might just think, this Wi-Fi sucks. It didn't load my page very well. It's a good thing it loaded that login button, and I can still reach it. Maybe I could still transfer a lot of money to somebody. That's what I really want to do on this crappy Wi-Fi. Sure I do. So anyway, so I put in PayPal user at yahoo.com, and I'll put in top secret password. I'll put a 12 at the end because I'm typing it pretty badly. There it is, horribly misspelled password. In fact, so bad it's not even going to show up in my grep. I've tried. There we are. And now, of course, when I log in, there it goes, stealing the stuff. There's Yahoo and top secret password. So, you know, this is, these old attacks, everything I've shown you is 10 years old, but it keeps on working until somebody fixes it. And the browser manufacturers are beginning to do a little bit for it. Storing passwords on a phone, though, this is a whole nother level of madness. I don't know who thought of that, and how did it ever become popular? You don't store the password in your browser to remember who the user is. Everybody knows you shouldn't do that, so why do they do it on the phone? It just seems like you've got people that have never written anything at all thinking the first thing that pops in their head. Anyway, yeah. Yeah. Well, no, actually, I'm glad you brought this up. Suppose you put a password manager on your phone, like OnePass. Great. It will store a copy of your password in an encrypted form, and then when you install Home Depot, it'll store another copy of your password in plain text, in addition to the one in the password manager. So it undoes the value of password managers. I mean, you end up with another copy of your password for every app. It's nuts. At the very least, you would store one copy someplace safe like the Android key store, and they would all share it. Or it's just crazy. And what it tells me is people are going for the bargain basement. They are outsourcing their Android apps to whoever will make them cheapest, and they're subjecting them to no security review at all. Because these are really basic mistakes. Apparently, all they do is test it for functionality and then ship it out the door, and nobody in the company has any clue that the customers might care about security, which, you know, this can't last forever. Yeah. If you use one password, it is very valuable because then you could use a different password at every site. And then if Safeway throws your password around, they only let people in your Safeway account. That's the advantage. And that's a huge advantage. If you really had a unique password at every site, then it actually would not be that important for them to handle your password properly because it basically would be a cookie. It's only good for one site. So that's why if you actually have the discipline to use a different password on every site, which I highly recommend, then you should do it. That's what started me is I started looking at data that was stolen and dumped by criminals, and I saw how bad the policies are at the server. People just have SQL injection and plain text passwords, and I realized I don't trust any of the services I'm using to protect my password. With the possible exception of like Google and Amazon, most of them are just not really knowledgeable enough to protect your password. So if I have an app like Safeway and I give them a password, I certainly don't want to use that password somewhere else because I don't trust them to protect it. But, you know, it's downright rude to be storing it on your phone in plain text. There's no need for that. By the way, iPhones are hard to audit, and the only way to do it, which is kind of slow and painful, is to make an unencrypted backup and look through the backup because the phone is very encrypted. And as you know, even the FBI has an enormously hard time getting the data off the phone. So I would say in an iPhone app, storing your password in plain text is probably not a severe problem because the OS has totally got your back. And their layer of security will compensate for the lack of security thinking on the part of the developer. But Android is a whole different world. Although the latest Android phones are beginning to have whole device encryption, and that would be another layer of a barrier to get through. But you know, I'm just appalled that they would resurrect a practice from 30 years ago that was abandoned for a good reason, for apparently some kind of very minimal convenience. Yeah. Well, there are apps, you're saying to log in offline, there are people that do that. I've seen it, they have like a PIN that unlocks the app. So that people just pick up your phone, can't use it, but you can use it. There's no reason for that to be your password. It's, I'm not quite sure what thinking process leads to this, but I can see it is a very popular solution. So on some kind of developers forum somewhere, this is now the fashionable way to have the sign-in button work on phones. And I think they should knock it off. If there's any Android developers in the room, please don't hurt me. Anyway, so that's what I wanted to show you. Any more questions about anything? Well, yeah.
So there are places where if you were developing an Android app, what are the best practices?
Yeah, well, I had that link a while back. If you're going to store something, just don't store personal things on the phone. If you think you have to, you just haven't thought it through. You store a cookie, and you put that personal stuff on your server. And then when they talk to your server, they send you the cookie, and now you know whatever it is you thought you needed to know. which is fine, but there's no reason to be putting stuff on a phone. Phones are very dangerous places to put data. They're going to get lost and stolen and hacked. Yeah. Yeah, yeah. Which is kind of funny because, you know, the surveys show that people will not use .info websites because they feel they're full of malware, and indeed 90% of them are. Especially mine. I'm flagged on a lot of bad lists because I have a lot of projects that show people how to hack into things. But it doesn't have the kind of malware that infects you when you're just visiting. It has malware you download and use. I love my malware. Malware is cool, but under controlled conditions. But my page is often flagged by products. But anyway, that's at samsclass.info. You'll find this talk and everything else there. Yeah?
So you mentioned you're teaching an upcoming class?
Oh, it's partway through right now. Yeah, I teach a lot of security classes, but I'm teaching a crypto class to try to help my students do this stuff. So that's down here, cryptography for computer networks. And what's funny is the book has a lot of math, and I'm kind of skipping over that. I don't really care about the details of the math or the proof. I just care about learning how to use it in some simple language like Python, so you can get a clue how many inputs are there. There's the key, the IV, and the plain text, and here's the 5 or 6 modes available, and when you should use one and when you should use the other. You know, it's engineering. I'm not trying to invent new cryptography. I'm just trying to learn to make sure they all know how to correctly use the tools that are out there, because cryptography is very good. AES is effectively unbreakable. RSA is going to be essentially unbreakable until quantum computers come out, and that's at least 20 years out. And hashing routines like SHA-2 are perfectly fine. We have the tools to make your stuff really secure so nobody can get in if you just use them correctly. And it's not any harder to do it right than to do it wrong, really. But anyway, obviously people need some training. So, yeah. Any other questions? They do have an Android key store, and that would be a much better place to put secrets. What's even better is to not do it at all. I had a nice chart. Number 1 is don't store secrets at all. Number 2 is put them in the key store. That's designed for the purpose, and Google, of course, made a good job of encrypting that with the right encryption. And they did that so the developers do not have to understand encryption. Just use the key store and trust Google. That's perfectly fine. You're trusting Google with the OS anyway. You're never going to be any more secure than Google makes things, so don't even bother. This is why the fundamental rule of encryption is never make up your own encryption. In fact, you might like, if I open up another phone, I can show you another fun one. I might have a little bit of time here. I don't know if they're going to kick me out. But if in the spirit of not doing your own encryption, let me put up Burp. Burp is my man in the middle. It's Burp Suite. All right. And there we are. And let me bring up another phone. I don't know if you people have seen this. I did this DEFCON a couple of years ago. But this is a good example. There's a music app called, it'll come to me. If I get the right phone, it's right there. And this is an example of why you should never make your own encryption, is my plan here. Let's go to this old phone. I think that's where I put it. Yes. There we go. My phone is coming up. Let me make sure my burp is ready. I go to proxy and options, and I make this listen on all interfaces. Let's settle for 192.168.91.197. That'll do. All right. And my phone. My top secret password, which is not taking. Listen to me. How do you get rid of doing this? Yeah, that's right. Oh, thank you. It's just bothering me about stuff. Okay, good. It's telling me things that don't matter. All right. Thank you. So that's good. Snapchat. There it is, Stitcher. That's what I wanted to find. Stitcher is a music player, and they're a fine case history of why you should not make your own encryption. So I'm going to send the data through my proxy just so it's easier to see, which is that number, 192.168. 91.197. All right. And save that. And now let's open up, Okay, let's open up Glorious Stitcher and save this and go to History. And there we are. So Stitcher has a login option, and I can log in with an email account. So I'm going to put in test@aol.com and a password of PASSWORD. And when I log in, the data should be sent up to Stitcher. Ah, that's pretty awesome. Couldn't reach Stitcher. Maybe oh no, wait, now what's going on there? Let me try again. Okay. Oh, that's interesting. Anyway, I think I won't push this one. I just want to mention they've changed. Probably I just need to pay more attention to my setup. But the point of Stitcher is they actually encrypted their data with the Caesar cipher. They just moved the A forward 2 letters, the B forward 2 letters. It was just unbelievable. So if you just use a password of A, you get an encrypted password of 2x. And when it's B, you get 2y. And when it's C, you get 2z. And when I notified them, they said, well, what else should we use? And I said, there's this thing called HTTPS. And they said, what's that? And now they're using it. But I mean, this is why I say, please, I tell my students, if you think you have a new idea in encryption, you just need to understand how stupid you are. You don't. Number theorists since Pythagoras, the smartest people on earth, have examined everything. And whatever came to you in the shower, Pythagoras and other people thought of it thousands of years ago and hacked into it. And you really only want the 10 smartest people on earth to write encryption. And you just want to slavishly obey their commands. Just use standard things like AES and HTTPS, and you'll be safe. Whatever your brilliant idea is, just shut up about it. Find a mathematician you can talk to in private to tell you what an idiot you are. When I was a kid, I was 17, and I went to Harvard, and I met the Harvard Junior Fellows. I was applying there. I didn't get in, but I met the Harvard Junior Fellows in philosophy, and I told them my opinions about religion and the meaning of life. And I asked them, what do you think of that? And they said, oh, we think you need to actually take a philosophy course and have some clue what you're talking about instead of asking these stupid questions. And I didn't appreciate that answer. But they were right, of course. I had no idea what I was talking about, and they did. And if you think you know encryption, the odds are 99.99% that you are in that position. You don't even know how dumb you are. Now, talk to a real cryptographer and just do what they say. Cryptographers and nuclear physicists, you probably don't want to have a brilliant idea and think you're smarter than them. Anyway, any other questions? Well, I reckon that's it. Have a good trip back home. All right.